This is a kinetic molecular theory question. If a container has equal amounts of helium, nitrogen, and fluorine gas on a molar basis, and the container has a small pinhole in it at the end of some amount of time, and providing that there is some of each gas remaining, we want to know the relative amounts of the gas in the container, and we need to know your rationale. At the end of the amount of time, there'll be less helium than nitrogen and less nitrogen than fluorine. Now for the rationale. All three gases are at the same temperature, so they all have the same average kinetic energy. Kinetic energy is 1/2 mv squared, where m is mass and v is the velocity or speed. So if all three have the same kinetic energy, then mass and velocity are inversely related. Thus, the gas with a higher molar mass will have a slower speed. The slower the speed, the less frequently the gas particles will interact with the pinhole, so less gas escapes per unit time. The less gas that escapes, the more that remains in the container. Helium, having a molar mass of 4.003 grams per mole, is the lightest. Fluorine at 38 grams per mole is the heaviest, and nitrogen is in between the two. Thus, helium being the lightest will have the fastest speed, and so it will interact with the pinhole the most frequently. Fluorine being the heaviest will have the slowest speed and the least amount of interaction with the pinhole, and nitrogen being in between the two will have an in-between interaction. Therefore, the amount of helium has to be less than the amount of nitrogen, which has to be less than the amount of fluorine in any given time span